Section 6.3 on how to add and subtract rational expressions. When we want to add or subtract a rational expression, if the denominators are the same, then all we need to do is add across the numerators because the denominator is the same, just like when we add or subtract any fraction. For example, if I'm adding 1/3 plus 1/3, they both have the same denominator, so I can add across the numerators, and that would mean I have 2/3, as long as the denominator is not equal to 0, because then it would be undefined. So here's an example where the denominators are the same. That one's easy, right? Just add 3c plus 4c. Since they have the same variable, you can add the numbers in front, or the coefficients. 4 plus 3 is 7. Same thing goes for subtracting. We subtract straight across the numerator if the denominators are the same. Here is an example. We would just take 5 minus 1 and get 4x. Now let's look at this example. First, we notice we're subtracting. Then we want to ask ourselves, are the denominators the same? Yes, they are. So all we do is subtract the numerators. We'd get a -5 and write it all over the same denominator. You only have to write the denominator once, just like you would with any fraction. Subtracting. Okay. Sometimes not all denominators are the same, right? We end up adding 1/4 plus 3/7, and that means we have to find a common denominator. And to do that, we need to find the least common denominator, so we're not adding and then having to simplify and simplify to get our answer. It's a lot easier when we're working with just a single number. You know, what is the least common denominator between 2 and 3? That would be 6. When we're working with rational expressions, this is how we can find the least common denominator. The first thing we can do is factor each denominator completely. Then, the least common denominator is the product, so multiplication, containing each different factor. If a factor occurs more than once in any one denominator, the least common denominator will contain that factor repeated the greatest number of times that it occurs in any one denominator. Here's an example. 6 minus 2w is our first denominator. If I factor that out, both 6 and 2 are divisible by 2, so I can rewrite that as 2 times 3 minus w. 9 and 3 both have a factor of 3, so if I take that out, I now have 3 times 3 minus w. I notice that 3 minus w is the same, so I only have to write that once. It's repeated. It only needs to occur in one denominator. 2 times 3 can be multiplied, and that equals 6. So my least common denominator is 6 times 3 minus w. I was able to multiply these numbers on the outside because they were both on the outside of our parentheses, and they were both being multiplied by 3 minus w. So let's look at another example where we're not actually adding, or subtracting, we're just finding the least common denominator only. Okay, can I factor this out any further? That would be our first question. Factor both of these out further. So yes, I can, right? How can we do that? Well, we can rewrite 16 as 2x to the 4th power. And why did we choose 2? Well, because 56 also has a factor of 2. So our common factors between 16 and 56 are 2. So 56 can be written as 2 to the 3rd power times 7 times x times y to the 4th. Okay. So what's our least common denominator? 2 to the 4th power times 7 times x squared times y to the 4th. So what we do is what do we notice? Well, they both have a 2 raised to a power. But which one is the bigger power? I can't make a bigger number fit into a smaller number. I can make a smaller number fit into a bigger number. Right? I can't make 4 fit into 2, but I can make 2 fit into 4 by multiplying by 2. So I have to choose the value that is larger. So of these two, I would choose for the least common denominator that 2 to the 4th power. They both have an x. Of the two, which one is bigger? X squared. So that's the one I'm going to choose for my least common denominator. They both have a y. And again, of the two, which one's bigger? Y to the 4th power. So those are the ones I'm going to choose. I can, cross off or ignore the other ones I didn't choose. Sorry, guys, you didn't make the cut. And then what remains is that 7 is all alone. It's the only extra number that doesn't match. So I have 2 to the 4th times 7 times x squared times y to the 4th. If I combine that, I now have 2 to the 4th is the same as 16, and 16 times 7 is 112. So my least common denominator is 112 x squared y to the 4th. Here's another example finding the least common denominator, and that's all we're focusing on in this section. So first thing is factor each denominator. The first one is x minus 4, x minus 1. The second one factors to x minus 1, x plus 3. So what do I notice? I notice that these are the same, so I only have to write it one time. The other ones only appear once, so I will write them as well. So use the factor that is repeated the greatest number of times. That's our x minus 1. We'll use that one time. So this whole thing is our least common denominator. Okay, now we can try adding with that least common denominator. Here's a simple one. The least common denominator is x times y. To get the fraction on the right, to have a denominator with an x, I'd have to multiply by x. I can't just multiply the denominator by x because that would change this whole fraction. I have to multiply it by 1 for it to not change. So for it to equal 1, I have to multiply both the numerator and the denominator by that same value of x. So that's how we end up with 9x and x times y. And then we can add 8 plus 9x. But we can't combine them because they're not like terms. There's no x over here with that 8. Here's another example. This one's a little bit more in depth, a little bit more challenging, right? So this was the one we already did. We already found the least common denominator 2 slides ago, that it equaled 112x squared y to the 4th. So then using that, how do we go further, right? How do we add this? So let's look at what we're starting with. So this is what we're starting with. This is what we're being asked to add. Nothing's changed. In the first expression here, with this 11, we're multiplying by 7y over 7y. And in the second expression here, we're multiplying by 2x over 2x. So let's look back as to why we might be multiplying by 7 and by 2. Let's look back at this expression here. Right? So what was different? What was different here? In this expression, we had one more 2. So we'd have to multiply by 2. And in this expression, we had a 7 that didn't exist in the first one. Okay. why would we multiply by a y and an x? So let's look. So we chose, look at it again real quick, right? 7 and y were together, and 2 and x were together. So we have 7. This one had the extra y, right? So we have that y, so 4. And 2x, this one had the extra x. So what do you notice? That the items that we circled, this 2 and this x, that's what we ended up multiplying by. We had one extra 2. It was 2 to the 4th power compared to the 3rd. And over here, we circled the 7 and we circled the y. Those were the ones that we had that were extra that we chose for our least common denominator. So to make these equal, we'd have to take our 56, our value with our 56 and multiply that by 2x, and we'd have to take our value of 16 and multiply that by 7y. And that's what's going on here, right? So we took our value with our 16, our first expression, and multiplied it by 7y, both top and bottom. And then take our value of 56 and multiply that by 2x, both top and bottom. Because this is the same as saying we're multiplying by 1, we're multiplying by 1. So we're not changing the value, we're just making it so that we're able to add so that the denominators are the same. So we've already multiplied this together. We know that when we multiply these two values, we're going to end up with 112 because we found the least common denominator. So the only thing we end up multiplying is we have to multiply this first, 77, and second, 34, and then we can actually add them together. But because the variables are different, we have to keep it separate as 34x plus 77y. Subtracting least common denominator is what we want to find first. Least common denominator between x minus 3 and 2x minus 3. Well, let's look at, can we simplify this? 2x minus 6. Each can be divisible by 2, so it'd be x minus 3. So 2x minus 3. So what's missing over here? We'd have to multiply this fraction, or this rational expression here, by 2 for this to be 2 times x minus 3 to make that look the same, right? So that's what we're going to do. We multiply this first fraction by 2 over 2. The second one doesn't need to be multiplied by anything because it is the least common denominator. And once we do that, we now have 10x plus 12 in the numerator, and x minus 2. We can subtract those. This will be 10 minus 1 is 9x, and 12 minus 2 is minus negative. Sorry, minus a negative. We have to remember that we're subtracting a negative 2, and so that would be why we end up with 12 plus 2, which is 14. It's our last example here. We want to find the least common denominator first. So x squared, this is a squared minus b squared, because I noticed 16 is a perfect square. So we have x plus 4, x minus 4, and on the right fraction here we only have x minus 4. So along the side here we can say, well, to get that to be written over the least common denominator, we'd have to also multiply by x plus 4. And not just in the denominator, but in the numerator. So that's what we're doing over here. So we'd be left with 4x plus 16 or minus 16. The only because this is a negative 4 because that negative sign here. The only interesting fact is that when we do that, we're left with x minus 4 in both the numerator and denominator, so that could cancel and simplify it out to x over x plus 4. But here's our least common denominator. When we simplify the numerators, then we're left with 8x minus 4x minus 16 as our final answer.